Everyone, and welcome to my YouTube channel. So here today we are going to be doing the introduction to inequality. So here we are just going to be looking at first the simple ones, then we are going to progress like that. So solving an inequality is similar to solving an equation. So the first thing that we're going to do is open the brackets. So we have 3 times 2. 3 times 2 gives us a 6x. 3 times -1 gives us -3. Should be less than our 8x minus 7, like that. So we are going to collect our like terms. Let's say we take the 8 this side. So we have our 6x. Then we have minus 8x. Should be less than. We have a -7, like that. We take our 3 there. It will be +3, like that. Then what we are going to have after doing this, we are going to have our 6x minus 8x. This gives us a -2x, like that. Should be less than -7 plus 3. This gives us a -4, like that. Then we are going to divide. To leave x alone, we divide by -2, -2. So by doing that, what we are going to get, x should be greater than 2. So each and every time you, let's say, multiply an inequality by a negative or divide an inequality by a negative, the sign changes. So in that case, but if you have, let's say, your 2x should be less than a negative number such as -4, when you divide this, the sign does not change. It only changes when you divide by a negative value or you multiply by a negative value in that sense. So this one, the sign will just be the same unless if you're dividing by a negative. That's the only exception. Like let's say, for example, we have our -x is less than our -4. So in this case, either when you divide by a -1 on both sides, the sign will change to say x is greater than +4. If you want, for the same problem, you can tackle it in this way, where you choose to multiply -1 on both sides. So if you multiply an inequality by a negative or divide an inequality by a negative, what begins to happen is that the sign changes the direction, like that. So we are going to come up with our solution set. So our solution set simply shows us all the values that are working. So if we look at this, they are telling us that our x is greater than 2. So what does this mean? This means that your x value could be equal to 3. It could be 4. It could be 5. It could be 6. It could be 7. It could be 100. It could be anything. So now the list continues to go on like that. Now the problem is that we don't know what could be the highest possible x value. So it could go on to say we might have 10, 0, 0. All these are values of x. These are values that x can take. So therefore, to give this as an interval notation, now take note that this means that x should be greater than 2, meaning to say 2 should not be included. So what we use to show that 2 is not included, we are going to use this open bracket. This open bracket means 2 should not be included. Then we are going to say, we are going to put a 2. So this means that 2 is not included, 2. Now we are continuing. X could be 3, 4, 4,000, 1 million, 1 billion, a trillion. So meaning to say the highest possible value of x should be a positive infinite. So a positive infinite, meaning to say we are not ending there. Now that means to say the positive infinite, you can never reach an infinite number because the numbers are continuing to grow like that. So that means to say this is our solution set. These are the all possible solutions of x that would work. So let's continue with another. Let's say we have our 2, open brackets, 2x plus our 3. So for this one, the approach is the same. Multiply 2 by 2, it will give you 4x. 2 by 3 gives you 6, less than or equal to. We have our 6 times x, it will give us 6x. 6 times 2, it will give us -12. Then we have plus a 10, like that. So what we are going to have is, let's decide to take the 6x this side. So we are going to have our 4x. Then we have -6x, like that. Should be less than or equal to. we have our negative 12 plus 10. This gives us a negative 2. Then we take the 6 this side, we are going to have our negative 6 like that if we take it this side. Then what we are going to have is our 4x minus 2x minus 6x. This gives us a negative 2x like that, should be less than or equal to our negative 8 like that. So what we are going to do is we are going to divide by a negative 2, so that our x becomes greater than or equal to 4. So each and every time, so negative 8 divided by 2 gives you 4. So if you're dividing by a negative, the sign flips like that. So this is a similar result. They are telling us that our result is that x is greater than or equal to 4. Now what does this mean? That means to say x can take values that are greater than 4. It could even be 4.1. That's the pressure. It could be 4.2, but the values are increasing. It could be a 10, it could be a 20. All these values are greater than or are greater than 4. Then we have our 30, we have our 100. The values keep increasing. We could have the zeros could keep increasing like that. So now, due to this ambiguity, we can now be able to come up with a interval. So the interval of this value, if we are saying that our x should be greater than or equal to 4, it means to say in terms of our solution set, we can be able to say that this one will be, since 4 is the lowest value, that x could be greater than or equal to 4. That means to say 4 should be included. So we are going to put these square brackets to show that the first value you mention is included, comma. The highest value of x in this case is that it will be a positive infinite like that. So you use these brackets to show that it's not included. Just for reference, just in case the answer that we found was something like x should be less than or equal to 4. What this means is that your x value, since we are saying that should be less than or equal to 4, it means to say your x value could be 4, but other values should be less than 4. Let's say it could be 3.9, it could be a 3, it could be a 2, it could be a 1, it could be negative 1000, it could be negative this value. We can keep adding the zeros. Now what this tells you is that the lowest possible value of x, if it was x is less than or equal to 4, that means to say your x value should be equal to, we are going to say in terms of our solution set, we can say that this value should be our smallest value. Since it's reducing, it means to say we are going to use an open brackets and say negative infinity to our 4. Now in this case, this 4 less than or equal to means 4 is included, so we can do this if the solution was like that. Let's look at our last problem. Let's say we have this problem. So this problem can be answered in two ways. Either to consider this as a whole, where we can be able to say that our negative x, so we have our negative x less than or equal to 3x minus 5. Then we have our 7 like that. So the first approach, where we can just be able to make sure that we just add the additive inverse of negative 5. So in other words, we need to eliminate this 5. So what we can do is we can add a 5 here, we add a 5 here, we add a 5 here. So what this means is that we are going to have a negative 8, we add a 5, we have less than or equal to our 3x, we have minus 5, we add a 5. So by adding a 5, this goes. Then we have our less than, our 7 like that, we add a 5. So whatever number you add it on all the points. So we have our negative 8 plus 5 gives you negative 3 less than or equal to, we have our 3x, our negative 5 plus 5, that's 0. Then we have our less than, we have 7 plus 5 gives you 12. From here you can divide a 3 like that, divide a 3 like that, divide a 3 like that. So we are going to end up with our negative 1 less than or equal to our x less than, we have 12 divided by 3. Since 3x divided by 3, that means this and this one cancels. Then here we are going to have our x is less than 12 divided by 3, will give you a 4 like that. So this is our answer. So that means to say our solution set, we are going to have, if you can see, your x value is less than or equal to 1. That means to say we are just looking at numbers such as from -1 to 4 like that. So we are just looking at values that are in between these. So now if you look at the values that are in between these, we are going to have our interval is that it will begin at -1 with -1 included, since it's saying that less than or equal to. Then we are going to have our last value is 4, so we are going to put 4. Now as you can see, this means that 4 should not be included, so we are going to do this. So this is how you can solve that one. If you are not comfortable with this way, you can just isolate the problem by doing this. So what we can also do is that we can just split this by doing this. First we say -8 is less than or equal to our 3x minus 5. Then we also have our or. We can say our 3x minus 5 should be less than 7. So we isolate, we let this part of the inequality stand out first. Then the other part, we also let this other part of the inequality stand out. Then we can just solve them separately. So taking the 5 this side, we can have -8, we have plus 5 like that, less than or equal to our 3x. So our -8 plus 5 gives us a -3, less than or equal to 3x. Then we divide by 3, So pay attention that the sign is not changing. It's -1 is less than or equal to x, and like having -1 is greater than or equal to x, because of you are dividing by a positive. You are not dividing by a negative. Then the other part of the equation is that we have our 3x minus our 5 less than 7. So we take the 5 the other side, we are going to have our 3x less than our 7. Then we add a 5 like that. So we are going to have our 3x less than 7 plus 5 gives us a 12. Then we divide by 3, we are going to have our x is less than a 4 like that. So either way, we can conclude to say we can combine these. We have our -1 less our x, then we have our less our 4 like that. So this is how it's done in another way. Thank you very much for watching the video. Hope you would like, subscribe and share for more.